Hello everyone. So this is the presentation for our Mechanism Sessional group project, and the topic we have chosen for the group project is garage door mechanism. So this is our team, myself Arbud, and the other team members are Yuvraj, Kunal and Ankit. The objective of our group project is to design a garage door mechanism using a pure linkage system without any rollers or sliders. The constraint of this design is to avoid any prismatic pair, and we must only use one revolute joint to avoid friction and maintenance issues. The input of our mechanism is purely driven by a motor, and the door must be retracted flat against the ceiling to maximize the usable space or the internal space of the garage. So our design is basically a 4-bar linkage mechanism, and the links that are present in the mechanism are the garage door, which acts as a coupler, the input link which connects the motor to the mechanism, and lastly the follower link, which is the link that guides the path. So what are the advantages of this choice for our design? It eliminates the noise and jamming issues of the traditional track based door, and it is simple to manufacture using standard bar stocks.
Hello, this is Ankit, and I will be walking you through the manual drawing of the garage door mechanism, our Mechanism Sessional group project. And so let's get started. To begin with, we defined 3 positions for the garage door, which are the closed position. As you can see in the diagram, this is the vertical position, and an open position, which is the horizontal position, which you can see in the diagram as well. And as we know, for 3 position synthesis, we need an intermediate position. We can actually take any positions, but for design purposes we have taken the closed and open positions, and we have also taken this intermediate position for a clear design. So we have located the 3 positions, and now we have identified 2 attachment points, which are marked by A and B, and in the 3 positions they are like A1 B1, A2 B2 and A3 B3, as you can see in the diagram as well. And after that we traced the displacements of points A and B all through the positions, by which I mean that we just connected A1 and A2 points and then A2 and A3 points, and therefore we obtained the line segments. And similarly we connected B1 and B2, and then we connected B2 and B3. So from the principle of 3 position motion generation synthesis, then we drew the perpendicular bisectors of the segment A1 A2 and then the segment A2 A3, and we obtained the point at which the perpendicular bisectors were meeting. So this is one of our ground points. So that is nothing but O2, which I will show you in the next slide. So anyway, and similarly we obtained the perpendicular bisectors of B1 B2 and that of B2 B3, and we also connected them, which gave us the position of another ground point, which would be our O4. So as you can see in the picture on your left, we have located the points O2 and O4 by connecting the perpendicular bisectors of the A points and the B points, and those are basically our 2 grounds, as I mentioned. And after that, in the picture on your right, we have sketched the grounds. We have marked O2 and O4, and we have also shown the links in the intermediate position. The links are nothing but O2A and O4B. So as our garage door is nothing but a 4R mechanism, and the links are like O2A, A2AB and O4B. So these are our 3 links, and O2O4 is the ground. So like that said, we have synthesized the mechanism, and now I will be handing over the mic to my good friend Yuvraj, who will walk you through the simulation process of this synthesized mechanism.
Hello everyone. So my name is Yuvraj, and I will explain the CAD portion and the simulation of the garage door, which we will synthesize.
We then started designing the simulation based on the initial design.
But since we tried to copy or recreate the diagram as is, we ran into the issue that making a point coincident on a line in Fusion 360 makes it the equivalent to allow the point to slide on a line. So, due to this error, we had to change our approach in order to make it compatible with our software. So, in order to make our approach compatible with the design, we will only consider the effective length itself when we recreate the design. And we also use the endpoint constraint in order to fix the points to the line itself so that it does not slide across the line as was the case earlier in the software. This allows us such that the intermediate line can move freely and that the construction lines which are associated with the intermediate line can also move freely, and we can adjust both of them according to our needs. As was done earlier, in our problem sheets, we now construct a perpendicular bisector to the construction lines by using a midpoint and a perpendicular or a 90-degree constraint, as shown by the blue line. Now we do the same construction for the rest of the lines and we convert those blue lines to construction lines. And now we can freely adjust the intermediate position to choose a suitable position for the hinges, taking the original drawing as a reference. After finalizing the intermediate points, we measure each and every single dimension in order to recreate the whole design in a simulation software. The mechanism which we have hence created is a basic coupler door with an input crank which is a wall mount and a guide link which may either be a floor mount or a wall mount depending on the circumstances. This mechanism hence creates a swing and a lift motion which minimizes the space which is required by the mechanism itself while opening or closing the door. After importing and recreating the design, here we chose to show the hinges by a triangle symbol and the driving motor is shown by a gear icon. We had to trim off a small portion of the top of the garage door to account for the width of the garage door and for the other errors. So we also performed several simulations with both the linkages as the driving link while assuming the gate and links as stainless steel with a density of about 8,000 kilograms per meter cube. For this process, in order to analyze the critical torque which was required by both the linkages in order to perform their function, which was the opening and closing of the gate.
Hello, this is Kunal and I'll be talking about the innovations in our design. So first of all, we have chosen the shorter link as the driving link. The main benefit is that it allows for a compact motor mounting location higher up on the wall. Also, the power required to lift the garage door to its topmost position is minimized as the length of the driver is small. So moving on with the analysis, the link material was assumed to be lightweight steel of density of around 8,000 kg per meter cube. Then we simulated the mechanism under various motor torques. The final result is that we determined that the limiting torque for the longer link was approximately 4 times the limiting torque for the shorter link. This data helps us in selecting the most cost optimal motor rating, preventing overspecification. And this can also help us calculate the minimum torque threshold required to initiate motion in the garage door from the dead vertical position. Also, what we are seeing is just the side view. Basically, there are two of these mechanisms on either side of the garage door. Basically, this is just a scaled up design for optimization purposes, and the simulation just analyzes the force and is performed to find out which link requires more force to lift and by how much as a rough estimate. So moving on to the advantages of our design. First of all, we have got zero vertical clearance. The mechanism requires no housing box above the door. This maximizes the vertical opening height. Next, we have minimal interior footprint. The door hugs the ceiling, leaving the garage volume free for parking. Also, this is a low maintenance system with only 4 revolute joints and no tracks. The system is virtually maintenance free and completely silent. So, we successfully synthesized a 4-bar linkage to replace a standard track-based garage door. The design meets all the required constraints, no higher pairs, a compact opening and automatable. The simulation validates the motion generation, proving that the door retracts fully to a horizontal position. So these are the various resources that we used for building the project. Thank you for watching till the end.